Hey guys, today I'm going to talk to you about how spectacle lenses are made to a specific prescription. The process starts off with what we call a blank. A blank is a thick lens with a certain power on the front surface. Depending on the prescription you want made, this power can range, but it's typically around +2 for a lower plus or a minus prescription. The actual power that this lens will have is the difference between the front and back powers. So assuming that the front is +2, if we were to grind -3 on the back, the lens power would be -1. Now I know that sounds confusing, but when I'm saying these numbers, the important thing to remember is that these numbers, +2, -3, they represent the curvature of that lens. A plus curve is a convex, and a minus curve is concave. To make a lens look pleasing to the eye, we typically put a plus curve on the front with a minus curve on the back, and that makes what we call a meniscus lens. Now how that translates to what we actually do is we have to tell the computer what the power on the front surface is and what the power we want on the back surface in order to create a lens of a specific power. The lens I make in this video is actually a final power that has cylinder, but we'll just talk about the spherical powers for today. I want my sphere power to be -0.75. So if I have a lens that has a front surface power, or what we call a base curve of +2, I need to grind a curvature of -2.75 on the back. 2 minus 2.75 equals -0.75. So I punch that into the computer, and then I attach my lens to what's called a block. That is the metallic blue part on the left, right here. This green part in the middle is wax, and that's just what's holding the block onto the lens. So once I have my block attached, I load the lens into a machine with special tool heads to grind my chosen power on the lens. This machine reduces the lens thickness to something more usable and roughly grinds the power. If you watch the lens spin here, you can actually see the thickness changing. That's because of the cylinder that's in this lens. A lens with no cylinder, which we call a spherical lens, would have the same edge thickness the whole way around. The lens comes out of the machine with almost like a snail shell pattern on it, these circles here. The next step is to remove these tooling marks by buffing the lens. This is done on another machine. We choose out what are called laps. Laps are discs with different powers on them that match the powers that we want to create on the lens. So the laps are fitted with almost like a sandpaper. It's very fine. There is one that's more coarse, which is the black one, and then there's a finer that's blue. Once we've finished with both of those, the lens comes out looking like this. It's a lot better than before, but it's still a little foggy if you were trying to look through it. Our next step is to polish these lenses. So using a very similar machine and the same laps, we polish the lenses in a solution that almost looks like milk. It's actually a polishing compound, and attached to the laps here are buffing pads instead of the sandpapery ones that we used before. After 2 minutes on this machine, our lenses are completely polished, and then we remove the block, and voila, there's your finished lens. If you actually look here, you can see the change in thickness from when we started out. Anyways, thanks for watching. Please feel free to like or comment on the video, and I'll be sure to add more videos like this in the future.